Hello, this is Roberto and this is the HVAC is my channel. Today we're going to be talking about ventilation mechanical code requirements, alright? So let's get into it. So as I was showing in other videos, depending, number one, you need to know your location, okay? Based on the project location, you're going to be able to find the code based on the location. And this doesn't matter if you are in the United States or you are in another country, Dubai, India, Latin America. Every place has their internal codes, local codes, depending on their jurisdiction, okay? But if you don't have any code also, it's always a good reference to go to the International Mechanical Code. Okay, so we're gonna go here to the International Mechanical Code. So the question is, why do we ventilate? Why ventilation is very important? Because when we're doing HVAC design, for residential or commercial, one of the first steps is to do ventilation calculations, right? Ventilation calculation, and then after that we do the heat load calculation. Okay, regardless the system that you have, if you have a VRF system, if you have like a normal single mini split, whichever type of calculation, this is the process. So this in HVAC, this is one of the most important parts, which is the ventilation and heat load calculation. But the question comes like, why do we ventilate? And then it makes a technician or an engineer more professional to know about the code. Okay, so that's why I've done other videos for ventilation calculation for commercial and for residential. But in this case, we're going to check why. Why do we need that? So based on the International Mechanical Code, depending on the location, as I was mentioning. So I always put an example. Let's put in here, we can do Washington, D.C., New York City, Virginia, Kansas City, whatever. So let's choose, for example, Virginia. So in Virginia, USA, okay? So since you know where the project is, then you can go to the website. You don't even need to buy actually the book itself in Amazon, or you don't need any resource because it's online and it's available. So check up codes as I was showing in my other video, or check the ICC in the website. Just type in ICC and type it in Google ICC, and you will be able to find the International Mechanical Code. Type in Google Virginia or Upcodes Virginia, you will be able to find all the information in there, okay? So since we do a Virginia, USA as an example, then I know my location. In that case, since we know all that already, in Virginia, they have the Virginia Mechanical Code, okay, 2018, okay, which is pretty much based on the IMC International Mechanical Code 2018. There we go. Okay, but now this is what we have to analyze. When it's IMC 2018, it's based on that. Then for ventilation, what you see on the, I'm going to put this in pink, what you see on the right side are the sections for ventilation. For example, you have 3 options for ventilation, and I'm going to put in here. Well, actually 3 options. Let's put actually 5 options. What are your options for ventilation, to provide ventilation to your house? Okay, I'm going to change back to green. Okay, let's go green. So what are the 5 options? Option number 1, option number 1, let's put that in there. No ventilation. Okay, no ventilation. Okay, so usually in the past they didn't used to put ventilation at all. Why? Because they used to rely on air leakage. So the houses were not well insulated. So in other words, the fresh air would come through the cracks naturally, right? So that's what I would call no ventilation. Okay, so what about number two? For about number two, we're gonna put in here, let's call it natural ventilation. Natural ventilation. Okay, so for option number two, that also that complies actually with the mechanical code. Now, if you want to comply with the mechanical code, no ventilation is not an option. But now you can see option number two, natural ventilation, is also an option. It's not the most effective one, but it is actually backed up by the International Mechanical Code. And if someone asks you, like the code reviewer asks you why, you can always go to the section, right? So what I'm gonna do in here is I'm gonna put this in pink. See, if you can see on this side, this is the natural code, natural ventilation. So natural ventilation, go to section 402 of the International Mechanical Code, IMC, International Mechanical Code, and pretty much they say that you can ventilate through the windows, doors, louvers, and other opening to the outdoors. And if you read this section, they're also going to tell you about 4% area. So it goes deeper. It goes really deeper. And also, what would you consider natural ventilation? Okay, in normal projects like regular projects, I don't see natural ventilation. Mainly is mechanical ventilation, where they put a fan or supply air, whichever. However, natural ventilation is when you're trying to get possibly different strategies to get energy efficiency, like, passive houses or net zeros, or they're trying different ways to save energy. So, well, if you're going into different strategies, natural ventilation might be another option, right? Okay, so in those cases, you have that. Okay, so that would be option number two. What about option number three? Let's go to option number three in here. Option number three, and this is the most common. This is the mechanical ventilation. Technically, you're gonna force air. Mechanical ventilation. Okay, mechanical ventilation. Okay, so mechanical ventilation means that you're gonna put something in order to comply with this requirement. And what is the code section? So anytime you do HVAC design, you always have to refer to sections or to codes. So that makes a technician more knowledgeable, more professional, and an engineer more professional and more knowledgeable. That is the reason I'm doing this HVAC in my channel, and also this video, to just do some kind of code review, because many of the subscribers were asking me, like, okay, what's the code? Which code is this? Which code is that? So, well, it's very important. It makes a person more professional. So for mechanical ventilation, we have actually three options. Okay. So what is option number one? So mechanical ventilation is the most important one. So mechanical ventilation, we're gonna put option one, option two, and option number three. Okay. So option one is gonna be the exhaust only. Exhaust only. Exhaust only. Okay. The other option is supply only, or they call it also fresh air strategy, supply only. Okay, and the other section is balanced method, supply only and balanced. Okay, so remember, what are you doing with the ventilation? You're going to comply with code mechanical ventilation, option number 3, right here, and then you have to choose one of these three options. Exhaust only ventilation. See, I'm gonna put in here ventilation. Okay. Option number 2, supply only ventilation. And then option number 3, balanced ventilation. Okay, I think I did this in other videos, but it's good to be redundant a little bit, because it's very, very important. Okay, so now what is the exhaust only ventilation? There is a negative and a positive. Exhaust only ventilation is going to keep your house under negative pressure. which is not good because it relies on the cracks to bring outside air. So this usually is accomplished by having a fan in the bathrooms, okay? And in the bathrooms you can have an intermittent or continuous. So what is this is negative pressure. So in supply only, this is positive pressure, which is good. And then balanced ventilation is neutral. Okay, neutral. Okay, so this is the best. Balanced ventilation is the best. Supply only is the less than the best, but it's good. And supply only is just to comply, not the best. Not the best at all. So, but what is the difference in here? So I'm gonna put in here also the why they do exhaust only ventilation, because the home builders also take into account the revenue, and also they have to take into account how economical the house is gonna be. So whenever it's exhaust ventilation is low cost, which is an advantage at some point. Supply only has more costs, and balanced ventilation has more cost. Okay, so whenever I'm talking about balanced ventilation, okay, we're gonna put in here something else. We're gonna put something in here in red or white. Let's put it in white. Okay, so exhaust only ventilation is just gonna be a bathroom fan. I like exhaust fan. Exhaust bat fan. Bathroom, right? Bathroom fan. Bathroom fan, right? Okay, for supply only ventilation is gonna be another fan. So attached to the return air. Okay, so we are attaching an exhaust on the return, and this fan is gonna bring air from outside directly, right? Okay, the other one is going to be balanced ventilation, which is pretty much the HRV and the ERV. And I know one of my subscribers was asking me, make a video about ERV. So this could be kind of an initial video about the ERV, because that's the most efficient at the best part. So if you want to have like you have, for example, if your project is in Washington DC, and then the goal is to have sustainable project. For example, they are trying to get a LEED gold, or in fact LEED platinum, then ERV would be a good idea. Or if you're trying to get net zero, because it's more energy efficient, okay, more energy. So they wouldn't allow this exhaust bat fan. So in order to achieve those points, they would have to do ERV. So this is kind of the introduction for that. Okay, but now, as we were mentioning, I'm gonna put this in pink. We're gonna go check the code. Okay, so for the code, you have section number 402, natural ventilation, and then what is the section for mechanical ventilation? Mechanical ventilation, you have to go check the IMC, see IMC section 402. In the section 402, they define my ventilation has to be the following. See, section 403, I'm sorry. In the section 403, they indicate that you have to ventilate this, see, for group R, see, and which one is group R? Group R are the dwelling units, okay? Group R are the dwelling units. So in fact, I'm gonna bring this page onto this side. See, here we go. So if you look at this, we go to section. I'm gonna put this on the side right there. There we go. And then you go to section 403, mechanical ventilation. Mechanical ventilation, section 403. In section 403, they define mechanical ventilation shall be provided by a method of supply air. Now you know the method right here, supply only, right? And return or exhaust air. The exhaust air, right? Except that mechanical ventilation air requirements for group R2, R3, R4 occupancies 3 stories and less in height of upgrade plan shall be provided with an exhaust system, supply, and accommodation. So this goes more into definition. See, that's the mechanical ventilation requirement. Okay. So now we're talking about group R. What is group R? So group R is actually the definition, the occupancy definition. And where you're going to find this group R is actually the type of groups is in the IBC, International Building Code. Okay, so what happens is the architects in the beginning of the projects, they already have an assigned occupancy classification for each space. So in other words, they're going to give you like the drawings, like, okay, they have the drawings, the dwelling unit number 1, the dwelling unit number 2, the dwelling unit number 3. They will already have this classification based on the International Building Code. And in the classification, in the drawing, it is going to say, for example, classification R2, R2, in here it's gonna say, for example, let's go see in here R2 in the building, and in here it's gonna say S1, for example, depending on the occupancy classification. There you go. Okay, so what does it say? So what is a dwelling unit? A dwelling unit is classified again. So this section, section 202, general definition, is based on the IBC. IBC. Okay, so let's put in here IBC 302. Okay, so in the IBC, International Building Code 302, you have occupancy classification and use designation. In that occupancy classification and use designation, you have this classification. So where are you going to provide ventilation? You're going to provide ventilation depending on the space where you want to ventilate, because you're not going to ventilate that storage room, right? There's not so many occupants. But in here, for example, in the IBC, again, I don't want anyone to get confused on this. The IBC section 302 indicates occupancy classification and use and designation, and they have this table, okay? In this table, they have different categories. For example, assembly, business, educational, factory, hazard, institutional, residential. And so this is more for commercial, but if we're talking about residential, this is more for residential. See, residential groups are going to be in the classification of code R1 until R5. And then you can still go to what is R1, R2, R3, R4, R5. So if you're doing a residential building design, most of the times in the dwelling unit you have R2 for no transient. There we go, R2. Okay, so what is R2? By the definition, it says residential occupancies containing sleeping units or more than 2 dwelling units, or more sleeping units or more than 2 dwelling units where the occupancies are not primarily transient. Okay. What is transient? Transient actually is when a person is there like for about 30 days. Okay, so no more than 30 days. 30 days. 30 days. Okay, so 30 days, that means that that makes it transient. Transient, which means actually R1 is for transient occupants. So I would say temporary occupants. So I would say in this case, they don't stay more than 30 days, R1. But in a dwelling unit, usually they live there. In multifamily buildings, in residential buildings, they live there. So they stay there for more than 30 days. So that's why usually we do ventilation for R2 category or R2 occupancy, right? And finally, we're going to have the other mechanical section, which is mechanical section 407. See, mechanical section 407 is mostly referred to group I2. What is I2? We're going to here see institutional groups I1, I2, I3, I4, and also healthcare. Okay, so in this case, whenever you're doing some healthcare, or they call it in section 407 mechanical ventilation for ambulatory care facilities and group I2, they shall be designed and installed in accordance with this code and HRV 170. Okay, so what happens is when you are doing your ventilation calculation, number one, you have to see the location to see the applicable code. Number two, you're going to check what type of ventilation you're giving it, mechanical ventilation, right? Number two, mechanical ventilation. Number three, are you going to check like if it's exhaust only, supply only, or balanced ventilation? Okay. In commercial, actually, we're going to put this actually in commercial is usually, I'm going to put in here in commercial. In commercial, we're going to put in here, usually they do the ventilation via DOAS. This is very common, DOAS unit. DOAS unit means dedicated outside air, right? Dedicated outside air equipment, right? I mean, let's do it again. Dedicated outdoor air system. Yeah, I'm gonna put that in here because that's also very important. Dedicated outside air system. That's more for commercial, more than the residential, for commercial. Okay, so that's going to be a dedicated, and also in there they have the ERV, and then they have to comply with energy requirements. Okay, so overall, let's make a summary very quickly on this. So the summary would be the following. Okay, so whenever you're doing ventilation, you have to comply with the mechanical code because you're doing mechanical ventilation right here, and then for that you can comply with this mechanical code section. So based on the location, for example, for residential, you have the formula. So the formula, and you can see in my other videos, is outside air, 0.01 of the area plus 7.5 number of bedrooms plus 1. Right? So that would be for residential, but this is for continuous because whenever you're doing ventilation, you have two options. It's continuous or intermittent. So this is the minimum outside air requirement for continuous. For example, I'm going to put in here an example. Okay, so in residential, you use this formula because you're going to have the area and the number of bedrooms. It's kind of an easy, straightforward question. So in here, as an example, my outside air is equal to 75 CFM. Okay, CFM. Remember, this CFM, 75 CFM, is for continuous ventilation, but so it technically should be working all the time, but that wouldn't be energy efficient. Nowadays, everyone cares about energy efficiency, so that's why we go to intermittent. So when you put intermittent ventilation, and I have that in other videos too, then you have different requirements. In this case, this is the minimum. So intermittent is going to be depending on the rating on the fan, maybe 115 CFM, depending on the rating on the fan. So you have to check the cut sheets of the fan. But it's always let's put continuous. It's continuous is lower than intermittent always. And then we always check for the intermittent ventilation, at least in residential. Okay, in commercial we can do sometimes continuous. Already, so that's for residential, and also you refer in residential to HRV 62.2 in residential, but in commercial you're gonna have HRV 62.1, and then pretty much this is going to be the tables. You need to check on the tables, and then that based on the tables you're going to be able to calculate your ventilation. And then if you are doing any medical facility, you do HRV 170. All right, I hope you enjoyed this video, and remember, the reason I created this channel is because to combine the technical experience with the engineering experience. It's always very important to know the code, so that way for technicians, they will have a professional answer for any installation they do. So they always would say, okay, based on section 403, we require mechanical ventilation for group R2 in the International Mechanical Code section 302. And also, this also complies with HRV 62.2, which is not a code, which is a standard. And in case there is a medical facility, we have HRV 170, and that's based on the Mechanical Code section 407. So if they give an answer like that, that shows how professional someone is, okay? All right, leave any comment, and then if you have any suggestion for other videos, let me know. And thank you for watching. HVAC is my channel. Like and subscribe. But see you in the next video.